welcome to Constructions and Loci. Just before we start, just a reminder that there is a notes chapter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. So just begin with a definition. A locus, the plural is loci, is a set of points satisfying a description. So if you are asked to construct the locus of points 2 centimeters from point A, then the first thing you are going to need is a ruler and a compass. If you see the word construct, then you're going to be dealing with ruler and compass. And the first thing we're going to do is we're going to take the point of our compass and place it at 0, and then pull out the pencil until the point is at 2 centimeters. And the reason for that is if I then place the point of my compass on point A and draw, then every single point that I am drawing at this stage is 2 centimeters away from the center. This circle here are all 2 centimeters away from point A. If you took any point on that circle and marked it, you could measure the distance and it would be 2 centimeters, no matter what. And so a locus generally requires a compass to give us the distance from a certain point. If we were looking for the locus of points 2 centimeters from line AB, we would need to think about the same thing. Now straight away you might pick up your ruler and turn it round and just measure up 2 centimeters. So you might go to your line and put your ruler on and mark 2 centimeters away above, and you might think, well, I need 2 centimeters below as well, and you are exactly right. But if we then move our ruler along again, there are more points. There's a point here that's 2 centimeters away, and a point here that's 2 centimeters away. And if we keep going, we'll find more points 2 centimeters above and 2 centimeters below. And so what that is telling me is that I'm going to need quite a lot of points to make this diagram. And so I'm going to take my ruler, and first of all I'm going to draw a line through all of the points that I've placed at the top. And then I'm going to take my ruler and do exactly the same underneath, draw a line through all of the points that we drew underneath. But if we think about it, there's also going to be points which were 2 centimeters away from the edge right over here. There'd be a point here, and if I took the ruler to the other side, we would have another point 2 centimeters away at this end. But also, if we just turn this ruler around, we're going to get the same idea. We're going to end up with a point that's 2 centimeters away here, and so on, going all the way around. And so how do we deal with that? Well, we use the same idea as we did before. We want our compass opened out to those 2 centimeters away, matched up and drawn with a little arc. And what you'll notice is they meet all of the points that we drew before. So everything on this green line here is now exactly 2 centimeters from line AB. Okay, so then we're going to construct the locus of points within 1 centimeter of the outside of the triangle ABC. Now with this one you may notice that we've got a different word here. We've got the word within 1 centimeter, and we've also got of the outside of the triangle. That's telling us that we're only dealing with areas around the outside. We're not thinking about what's going on inside the triangle. And the fact that it's within 1 centimeter is it's going to actually introduce a few more points that are required. But we're going to do the same again. We just need to first of all mark our 1 centimeter points away from the edge of the shape. And so in each case, we just need to mark on that 1 centimeter. And we only need 2 points to draw a straight line, so we can rotate our ruler now and draw those points in. and then do the same on the other two sides. So let's go down to the bottom, 1 centimetre away from the edge, and marked 1 centimetre away, done. And then rotate the ruler again and draw in our straight line. There we go. And the last one, we'll do it on the diagonal line as well. And so 1 centimetre away from the line, just mark it, and 1 centimetre from the line, mark it, and take the ruler and draw through those as well. So draw through the two points that we've marked. Done. Now, because this is a construction, there is going to be a need for a compass, and that's because we have these points on the corner. The points on the corner require an arc drawn from them. And so the same as before, we're just going to open up our compass so that we are at the same distance, draw in our little arc, do the same at point B, draw in our arc, and the same at point C, drawing our arc. And what we've done is we've drawn the locus of points which are exactly 1 centimetre away. So the line that we've drawn are exactly 1 centimetre, but that's not what the question asked for. The question asked for within 1 centimetre. And so what that actually means is the locus of points are actually everything within this area here. And so we actually need to shade to show that. So next what we're going to do is we're going to look at two very common constructions. We're going to look first at the perpendicular bisector. Now the word perpendicular means to cut at right angles. Bisect means to cut in half. So what we're trying to do is find a line which cuts the line between A and B in half at a right angle. And so the first thing I'm going to do is I'm just going to join together A and B with a straight line. And then what I want to do is I want to take my compass. Because it's a construction, I'm going to use a compass in each of these. And the first thing I'm going to do is I'm going to open out the compass so that it is more than halfway along the length of the line. Now if we mark it there, we can see that is more than halfway. And what I'm going to do is I'm going to draw an arc all the way around. Now, very importantly, with yours, keep this exactly as it is. So make sure that the size of your compass and pen does not change at this point. Okay, make it the same distance at all times. And all I want you to do is then go to B and do exactly the same thing. Now, what you will notice is that the two arcs meet at two different points. Those 2 points are very, very important. Whenever two arcs meet or intersect, that is going to be an important part of what we're looking at. Because what I want to do is now just line up those 2 points, and I'm going to draw in a straight line. And what I have done, if I take this away, I have now formed a line which is perpendicular to AB. They are right angles, and it is exactly halfway in between. Now that is the method, but the question is what it actually does, and it comes here. The perpendicular bisector is used to find the midpoint of a line segment. So here is my line. The midpoint would be right here. It's used to find the set of points, a line, equidistant from 2 points. So what that means is that every point on this line is exactly the same distance from A as it is from B. So if we measured the distances from A and B to each of those points, it would be exactly the same. But it's also used to find the region closer to one point than another. And so what we could say is, now that we've drawn in that line, anything which is on this side of the line, well, that must be closer to B than it is A, because we found it what's exactly the same distance, so anything to the right hand side of it will be closer to B. The next construction we're going to look at is an angle bisector of lines AB and AC. Now, obviously, the word angle, we're talking about this angle here, and bisect means to cut in half. So we're going to cut this angle in half by drawing a line. And so to do that, once again, we're going to grab our compass and we're going to point it right on the corner of our angle. And then all I'm going to do is open out the compass. And again, this one doesn't actually really matter how far apart it is, as long as you can cross both lines with your arc. And once you've done that, the key here is, once again, keep your compass the same distance apart. Do not move this compass in or out, leave it exactly as it is, and then move the point of your compass to where the arc crossed the line. And again, draw yourself another arc. You're going to repeat this process at the point where the arc crossed the other line, and you're going to draw another arc. And once again, you'll note that we've got here an intersection of those arcs. That is always the most important part of any of these questions. So all we're going to do is we're going to take our ruler and we're going to line it up with the cross, and we're going to take a pen and draw in our angle, and draw in our angle bisector. There it is. And what that has done, it has cut this angle in half exactly. These two pieces are exactly the same size as each other. Now again, just like with the perpendicular bisector, what is the purpose of an angle bisector? Well, an angle bisector is used to find the points or a line equidistant from AB and AC. And so again, any point on this line would be exactly the same distance from this line as it is from this line. It's used to find any points closer to line AB than AC, or any points closer to line AC than to line AB. And again, this comes from our shading. If I looked at anything which was above the line that we've just drawn, well, those points would be closer to AB than they are AC, and vice versa. If I went underneath the line, well, those points would all be closer to AC than they are AB. And so our final set of examples, we're going to try and put together all of the different things we've looked at so far. And so for the first question, we have a rectangle ABCD, and we find the locus of points closer to point A than point B, more than 3 centimeters from point C. So we need to break this down. These are two different instructions. Closer to point A than point B. We have to think which of our constructions helps us to find that. Well, if we're looking for closer to point A than point B, that is our perpendicular bisector. And so the first thing we're going to need to do is draw a perpendicular bisector of A and B. And so what we need to do is just turn our compass around. Let's get to A and let's open out to more than halfway along the line, and let's draw in our arcs. Now what we need to do, we need to also do this from exactly the other side of the line, but as well making sure that that compass remains exactly the same distance apart, so that when we get our intersections, they intersect in the right position. I'm going to grab my ruler and I'm going to draw in my perpendicular bisector, through those 2 points and also going as far as I possibly can, because it's very important that the line continues as far as it can in any of these diagrams. Then the second part is telling us more than 3 centimetres from point C. If we're just dealing with a distance from a point, then that simply means we want to take our compass and we want to actually measure that distance. So 3 centimetres. Point of your compass on 0, point of your pencil at 3, and point of your compass on point C. And we're just going to draw in an arc. So the question was to find the locus of points closer to point A than point B and more than 3 centimetres from C. So straight away, if it needs to be more than 3 centimetres from C, that means we don't want anything within this section here, because they would all be within 3 centimetres. So we're only dealing with this section on this side of the blue arc, but we also want the points closer to A than to B. And so now we don't want anything above the perpendicular bisector. The only sections we actually want are these ones here. And so this is the locus of points that meet both criteria. We've shaded the area we wanted. Next, we're asked to find the locus of points closer to line BC than line CD within 4 centimetres of point A. So again, we need to be careful here as to what we're actually being asked for. So if we were looking for the points closer to line BC than line CD, the first thing is that must mean an angle bisector. And so we're looking for the angle bisector of BC, which is this line, and CD, which is this line. And so this point here is where we will be placing our compass. So let's take the compass, let's place it on point C, and let's open it out so that we know we are going to be crossing over both lines and then drawing in our arc. Now remember, with an angle bisector, the rule is that we move to where the arc met the line, and we draw another arc, and we do the same from the point where the arc crossed the other line, and we do the same. And what we've done is we've managed to form an intersection. That's the really important thing, because now we want to line up our ruler with that point of intersection. There it is, and we'll draw in our angle bisector. So there is stage 1 complete. Stage 2 tells us that it needs to be within 4 centimetres of point A. So in this case, I'm going to take my ruler again, and I'm just going to measure those 4 centimetres from 0. So I just need to open out my compass a little bit further. There we go. And we want to go to point A, and we want to draw in our arc. And so it has to be closer to line BC and CD. So if it's going to be closer to BC than CD, it needs to be above the angle bisector, and it needs to be within 4 centimetres of point A. And so it must be within this section here. And so the piece that I'm actually interested in is anything in this piece here. And very importantly, I am not colouring in this tiny little piece here. And so we come to the end with our exam question. It came from the Edexcel paper in June 2017, and it was foundation paper 2. And it tells us in this case that A, B and C are 3 points on a map, and 1 centimetre represents 100 metres. Point T is 250 metres from point A. Point T is equidistant from point B and point C. On the map, show one of the possible positions for point T. So, first things first here, we must just notice here we have a scale. This means we're going to be needing to deal with a scale drawing in this situation. And that comes in here where point T is 250 metres from point A. 250 metres, if we are going to use our scale drawing, we're going to have to divide that by 100. And if we divide it by 100, it is 2.5. That is telling me that this first piece of information is to do with 2.5 centimetres. So I'm going to grab my compass and measure 2.5 centimetres on my compass, and it was from point A. So the first thing I'm going to do, 250 metres from point A, well, that is a circle. It's a circle at point A. That is going to be enough in this question to get you at least a mark straight away. But the second one comes from point A is equidistant from point B and point C. What does it mean to be equidistant from 2 points? Well, what that means is we need a perpendicular bisector. And so what we're going to have to do is between the 2 points, open out so that we are more than halfway. I'm going to draw our arc from C, and we're going to repeat our process from B. Draw those in, and the point where those two arcs meet is going to be our perpendicular bisector. And so we just want to get that lined up. There we are. And draw in that perpendicular line. And again, we want to continue that as far as we possibly can, because it's important that this can go a long way. And so it asks for the point T. The point T is the point which is 250 metres from A and equidistant from B. And so it must be the position where our perpendicular bisector meets the arc around A. And so the only place that we have is here. This would be point T. Now on your diagram, if you're doing it along with me, you will actually have another point that's over in this area here, but it only asks for one position, and so T would be right there.